Okay, so remember that recently we talked about perfect square trinomials, and we talked about how to recognize them. Now, if we can get a perfect square trinomial, then it's going to factor to the form a plus b squared or a minus b squared, which is really, really nice. Now, if we can get that, then we could take the square root to be able to eliminate the squared, but that's only when we have a perfect square trinomial. So we have a tool called completing the square. The purpose of completing the square is to create a squared quantity so that we can use square roots to solve an equation. So to complete the square for an expression, we're going to look at just the x squared plus bx. And what we're going to do is we're going to take half of b, so b divided by 2, and we're going to square it, okay? Now, in order to complete the square, we always need it to be a 1. Oops, I'm on a yellow box. Let me fix that. We need it to be a 1 for the a value, okay? Because remember that this middle term is always 2 times a times b when it's a perfect square. So if a is equal to 1, then that's 2 times 1 times b, so that just makes it 2b. And then that way, to figure out what the last term is, I just need to take b and divide it by 2 to figure out what the last term needs to be, okay? So that's why that's going to work. If the middle term here is b, then I know that that comes from 2 times something, okay? And so to figure out what it is, I need to divide by that 2, which has absorbed the 1, and we're going to square that. So the rule is always going to be half of b squared, all right? And that is always going to factor to x plus whatever the b over 2 is squared. Now, remember that this could be plus or minus. So if it's a minus, then it's going to be x minus b over 2 squared. So that's what we're going to do, is add b over 2 squared. That's how we complete the square, okay? So now let's just think in general before we move on to the next page. If I just gave you something like x squared plus 6x, and I said plus blank, what would need to go in the blank to complete the square? Complete the square means add a number that makes it a perfect square. Well, we look at this and we see that this number is 6. The sign doesn't matter because remember, this is always going to be positive because we're going to square it. So it doesn't matter if it's plus 6 or minus 6. 6 is the number we're going to use. We're going to take 6 over 2 and then square it. 6 over 2 is 3, and 3 squared is 9. So 9 is the number that we add to complete the square. And then that's going to factor to x plus 6 over 2, which is 3 squared. Again, this sign is always going to match this sign. Whoops, my square didn't write down. There we go. So let's try another one. If I have x squared minus 10x, think to yourself, what's going to go in the blank? Half of 10 squared. Half of 10 is 5, and 5 squared is 25. And then to factor it, it's going to be x minus, because again, these signs are always going to match. What was half of b? It was 5. X minus 5 squared is how that's going to factor. So that's the idea of completing the square. Now, how do we use that to solve equations? Okay, so to solve by completing the square, remember that to complete the square, we always need just x squared plus bx. So instead of getting our equation equal to 0 like we did for factoring, we want to move the constant to the other side. So I want the x squared and the x by itself, and I want the c, or whatever the constant is, to the other side, okay? Then we're going to add half of b squared to both sides of the equation. Remember, in algebra, whatever we do to one side, we have to do to the other. So it's going to look like this. I'm going to have my x squared plus bx. I'm going to do plus something on this side, and that's going to equal c plus the other thing on the other side. And whatever we add, that's always going to be half of b squared. That's what it is that we're going to add to both sides, okay? And then we can factor it, and then because we have something squared, we can use square roots to solve it the rest of the way. So let's follow these steps through. So on number 5, here's our x squared plus bx. That's the part we need by itself. So I'm going to add 32 to both sides, and I'm going to leave myself a little bit of room for those fill in the blanks that I'm going to have. So I have x squared plus 4x, leave some room, equals 32. Now this is where I'm going to add plus blank, and if I add something on one side, I have to add it on the other side, okay? Now again, we're going to add half of 4 squared. That's what we're going to add on both sides, and you can do that in your head, but again, on your notes, you won't know what you did in your head, so you should write it down. Half of 4 is 2, and 2 squared is 4. So that's what we're going to add on both sides. Now on the left side, we want to factor that. And it should always be a perfect square. That's the point. So this is going to factor to x plus 2 squared. We completed the square because we want it to make a perfect square when it factors. It will always make a perfect square because we built it that way. And then on the right-hand side, 32 plus 4, those are like terms, so I can combine and I get 36. Now this looks like the kinds of equations we solved using square roots. I have a parentheses quantity squared, so now we can take the square root of both sides. So on the left, I get x plus 2. And on the right, don't forget, immediately following the square root, we get plus or minus 6. 36 is a perfect square. And then I'm going to subtract 2 from both sides, so I get x equals negative 2 plus or minus 6. Now don't forget, negative 2 and 6 are like terms, so we can go ahead and work that out. So if I do negative 2 plus 6, I get positive 4. And if I do negative 2 minus 6, I get negative 8. Anytime we can combine like terms, we are supposed to. So to simplify it all the way, that's what you need to do. Okay? All right, let's talk through number 6 together. So first step is to get the x squared plus bx by itself and then set up your fill in the blanks. So pause the video and see if you can set that part up yourself. So it should look like this. X squared minus 10x plus blank equals negative 7 because we subtracted it plus blank. Now you got to decide what goes in the blank. Half of b squared. That's what you're going to add on both sides. Half of 10 is 5. 5 squared is 25. That's what you're going to add on both sides of the equation. Now factor it. X minus 5 squared equals, on this side we're going to get, what, 18? Not a very pretty number, but it'll work. And now we're ready to take the square root. So if I square root both sides, I get x minus 5 equals, now 18 is the square root of 9 times the square root of 2, and the square root of 9 is 3 root 2, and don't forget your plus or minus. And then the last step is going to be add 5 to both sides. So x is equal to positive 5 since we added it, plus or minus 3 root 2. Now 5 and 3 root 2 are not like terms, so there's nothing else we can combine here. So on this one, we are done. And that is how we solve by completing the square. Okay, now on number 7, we have to do an extra step before we can start, because the thing that we need to remember on number 7 is that a has to be 1. Okay, so what we have to do to start is we have to divide everything on both sides by 3 because that's what a is equal to. When we do that, I get x squared plus 4x plus 5 equals 0. And now it looks like the other problems. So now we're going to start by getting our x squared plus bx part by itself, subtract 5, then complete the square. Okay, so I want you to pause your video, try number 7 and number 8 on your own, and then come back to check your answers in exactly 3 seconds. I'll be back with the answers. All right, here are your answers. So on number 7, notice we ended up with the square root of a negative number this time. So that means, remember, we get imaginary solutions. So the square root of negative 1 is I. So then I subtract 2 from both sides. We get negative 2 plus or minus I. Those are not like terms, so we cannot combine them. So negative 2 plus or minus I, those are our 2 solutions. And then on number 8, again, it doesn't matter that this is negative here. I still end up adding positive 4 to both sides. But the negative does matter because that makes it minus inside my factor. Versus on number 7, when it was a plus over here, then I got plus inside my factor. That's the only thing that changes. And so on that side, we end up with 2 plus or minus 2 root 3. So that is how we can use completing the square to solve a quadratic equation. This is really nice on equations that are not factorable. Like if we look at number 8, for example, if I had tried factoring this, I would get it equal to 0. X squared minus 4x minus 8 equals 0. If I try to factor this, what multiplies to negative 8 and adds to negative 4, I have 1 times 8. And 2 times 4, none of those pairs are going to work. So that polynomial is prime. It's not factorable. I also can't use square roots because it has an x squared and an x. But by completing the square, we made it so that we can use square roots, which is really kind of neat. That this strategy lets us use square roots when it wasn't able to use square roots originally. So completing the square is a really good strategy that we can use when square roots and factoring are not possible at the beginning of the problem. Okay, so that's how we can use that method, and now you can go do some practice with that.